was introduced by McBride and McKinney in this very nice paper, actually. So if you're interested in dependent types, you should check that out. The second part of the talk is taken from a talk given by Adam Kripala. And this is kind of a plug to tell you about this book, which is another great resource for dependent types. So maybe I'll put up the slides online, but these are two great links. OK, so this is Emacs, OK? And to use Agda, you have to use Emacs, which is a great thing. And what I have up here is kind of the window showing Agda stuff. On the bottom right, I've got this buffer showing what I'm doing with Emacs. It's not very important, but I thought it might be useful. And first, we'll do something we can do in Haskell. So we're going to define natural numbers. Great. So what I'm doing here is that I'm continuously reloading the file. And it's an interactive mode, so we can load the file and do a lot of other things with it. So in Haskell, what we would have is this. A natural number is either 0 or the successor of another natural number. It's very straightforward, maybe the simplest kind of inductive definition. And in Agda, we're basically saying the same thing more explicitly. So the first thing that we're doing explicitly is that these are the data constructors, and we're writing down their types manually. So when we write this in Haskell, what will actually happen is that 0 is of type nat, and suc is a function, is a data constructor, taking a natural number and forming a new one. In Agda, we have to write this explicitly. And this is because this data type is kind of simple, but there are more complex data types in Agda that need explicit type signatures. If you have used GADTs in Haskell, the syntax is very similar. But if you have not, it should be fairly straightforward. For what concerns this, which is probably the weirdest part of these 3 lines,